Martin and I are doing Module 7 review questions. We're starting with number 4. If a substance has 15, no, we did that in the last video, didn't we? Yeah. Starting with number 5, you read it.
Where do the protons and neutrons exist in an atom? In the nucleus.
That's right. Protons and neutrons exist in the nucleus. Okay. Number 6 says, why is it so hard to separate one isotope from another? Let's just remember what an isotope is by looking at page 206. Isotopes are atoms with the same number of protons but different numbers of neutrons. They're not like, one kind is the correct kind, and then there's like these odd ones that are the isotope that are like mutated or deformed or something. It's just what they are. So why is it hard to separate them, Martin?
They behave identically, chemically speaking.
Right.
So it's really difficult.
Right, because they have the same positive and negative charge. The difference is their masses, right? Yeah. Because the mass number is the total number of neutrons and protons in an atom. So that's why if you look at the periodic table, the mass number is this odd number because there's isotopes of the different elements and they have a different mass than each other. They're all isotopes. Okay, so all the types of an atom are isotopes of the atom, the element. Number 7. Well, your turn.
What were the differences between the plum pudding model of the atom and the planetary model of the atom? I actually don't mind if you take a second turn.
Oh, thanks. You're so kind. So who was the one who disproved the plum pudding model?
Rutherford.
That's right, Rutherford. It was not Rutherford B. Hayes. It was Ernest Rutherford. Okay, so Rutherford. So the idea of the plum pudding model was that there was a positively charged pudding and there were little negatively charged electrons like plums scattered throughout it. Okay, you can see that model on page 209. So Rutherford's model said no, they're both a type of particle, and the proton exists in the nucleus, in the center, and the electrons are whirling around outside, right?
Yeah.
Like a little planet, okay? So that was the big difference. He understood the proton, he understood the electron was a particle moving around outside it.
Your turn.
Number 8, if you have an orange light bulb and a violet one, which emits waves with the largest wavelength? Okay. So, which emits light of higher frequency? Now, he's asking us, don't look at the figures in the book. Just remember the name I told you to remember. What did he tell you to remember?
Roy G. Biv. R
Why?
for red, O is for orange. But it's a anagram.
That's right. And which, how does it go? Shortest to longest? Longest to shortest? Shortest?
It's shortest to, no, it's longest to shortest.
Red is the longest wavelength.
Yeah, violet is the shortest.
Okay.
I think blue is the most energy.
So compared.
So the largest wavelength.
Sorry, that's actually a grammatical error. It would be the larger, when we're talking about two things, the larger wavelength would be which one?
The orange one.
Correct. Which one emits lights of higher frequency? Remember, frequency is the speed of light divided by the wavelength.
So, and that would be
it's an inverse relationship, right?
Violet.
That's right. So the violet one will have the higher frequency, not highest, higher frequency, as it says here in the book. Which emits the higher energy light?
It's the blue. I think it's the violet.
The higher the frequency, the higher the energy. So correct. Good work. In case our video fans are wondering, this says guess who, but it's not him. Number 9. 2 light bulbs emit light of the same color.
If you can guess who it is, they will like you in the comments.
One, however, is much brighter than the other. What can you say about the wavelengths and the amplitudes of the waves being emitted by each bulb?
Well, in this one, we can take a look at the figures. So let's go over there.
Why? It doesn't matter.
One's brighter.
They're the same
so that,
color.
Yeah. But we can tell about like what amplitudes is.
I see. So you want to look up what does it mean about amplitude?
Yes.
What is amplitude?
No, that's why I'm trying to look it up.
Yeah, so amplitude, okay. So if you're looking at a wave going by, okay, amplitude is this, from the top to the bottom, right? It tells you how, whether it's got a low amplitude or big amplitude thing, okay? The wavelength is the distance from crest to crest or trough to trough, as it happens. And the amplitude is the distance between the crest and the trough. Okay? So, can you stop that already?
Sorry.
Let's look actually at the actual question then on 245. What can you say about the wavelengths?
So the brighter one.
They're the same color. What can you say about the wavelengths?
They're the same.
The wavelengths are the same. That's correct. Because they're the same color. One, however, is much brighter than the other. What can you say about the amplitudes?
The brighter one is greater.
That's correct. They have larger amplitude or greater amplitude in the brighter light. Number 10, moving right along. I'll let you write it down. Thank you. If an atom absorbs energy, what happens to its electrons? Okay, so in this module, we started learning about the orbitals. What do we mean by the orbitals, Martin?
We mean the stuff going around the nucleus.
Yeah, and what happened? What makes the difference between those orbitals?
The charge.
It's actually, the level of energy, right?
Yeah.
Yeah. So what happens if you add energy? If the atom absorbs energy, what's going to happen to the electrons?
They're going to move faster.
They're going to jump into higher energy orbitals.
Oh yeah, like so. So are there going to be more of them, or are they just going to move farther away from the nucleus?
Well, this is in the quantum mechanical model. It's today's model of the atom called the Bohr model. Okay? It's based on the Bohr model.
Boring, no.
So we assume, here it says on page 228. I misspoke. It's not the Bohr model. It's based on the Bohr model, but it's a little bit different. So today we assume that electrons do not orbit in fixed circles, but instead orbit in clouds or orbitals. Okay? In today's model of the atom, electrons can be at different distances from the nucleus, but still in the same orbital. All right?
Yeah.
So
the answer to the first part is they will jump to the electrons will jump to higher orbitals.
On page 229, the farther away from the nucleus the electron is, the more energy it must have. So they're often called the energy level. Okay? There are different orbitals within the orbital. Okay? There's the 1s, the 2s, and the 3s orbital. Then there's the p orbitals. And there's different energy levels. And they're slightly oriented differently. We're talking about the incredibly small stuff, right? So if an atom absorbs energy, its electrons will go to higher energy orbitals. The second part of number 10 says, if the atom is emitting light, what are its electrons doing?
Expending energy.
That's right.
So it'll do the opposite.
Yeah, and so the
jump to a
electrons,
lower orbital.
yes, are going to a lower orbital, lower energy orbitals. Okay, you ready for number 11?
Yeah.
You get to read it.
What is the concept of ground state and why is it so important in chemistry?
Okay, so on page 232, we see the definition of ground state, which you're required to memorize. The ground state is the lowest possible energy state for a given substance. This is important because the electrons in atoms will look for the lowest energy orbitals available. So matter tries to reach its ground state. Electrons will try to reach their ground state. Okay?
Yeah.
15-year-old boys try to reach their ground state.
No, I try to sleep. I never
Lowest
sleep on the ground. It's
possible
very
energy state.
Okay, so
for a given
I rarely
substance.
sleep on the ground because the ground is
You're well
uncomfortable and
grounded,
it gives
Martin.
me-
Number 12.
No, I'm not.
The three fundamental particles that make up the atom are the proton, neutron, and electron. Order them in terms of decreasing mass.
I order them to stop decreasing mass and increase mass.
So the neutron is the heaviest. The proton is next. And then the electron is
Unsurprisingly.
smallest. Okay.
Because it's negative.
Protons and neutrons are very close in mass, but the electron is 2,000 times lighter than the proton.
Mr. Incredible.
Science is fun. Thank you. Let's see if we can actually send this video.